Hey. Oh. Let's talk about interfaces. All right, so I just drove in on a car. You may not have seen it. It was a very special, invisible car called a Quingati. But I drove that car because I learned how to drive all cars. Now, if you can drive, and I asked you, can you drive a Honda Civic, or can you drive a Toyota Corolla, or can you drive a Ford F-150, you'd probably think I was being redundant because you'd say, I know how to drive, which means I know how to drive all cars. Let's think of that for a little bit. So I could have three totally different cars, a Ford F-150 and a Honda Civic, and let's say a Toyota Corolla. All of these cars I could have, and if you know how to drive, you can drive all of them, and for a very special reason. They all have the same interface. Every one of these cars uses a steering wheel to turn the car left or to turn the car right. It also uses a long pedal on the right that you press down in order to go, and a horizontal pedal on the left that if you press it stops. And without having this same common interface, we wouldn't be able to drive. I mean, if you think about it, you could turn cars a lot of different ways. How come some cars don't have pulley systems where you pull strings down to go left and right? How come you don't lean forward to drive forward and pull back to try to hit the brakes or to slow down? All cars have the same standard interface so that you as a driver can drive them all. And the same thing is true of a lot of files that we have on a computer program. Say, I'd want to be able to interact with a lot of different objects the same way. So if I have a common interface, I can learn how to use that interface, which allows me to learn how to work with all those objects. So we can imagine all of these objects having a connection to the same thing that we'll call a drivable. And this is what we call an interface. Right, so again, an interface is basically a set of actions that you need to be able to take that are common across other objects. So anything that claims to be drivable better have the same set of instructions or same kind of methods. So we could think of these as I need to be able to turn right, I need to be able to turn left, I need to be able to speed up, and I need to be able to slow down. Now, all of these cars are going to do these things slightly differently. So if you think about it, yes, when I turn the steering wheel to the right, my car goes right, but for some cars it might be more sensitive than others. And yes, when I step on the gas, I'm going to speed up, but some cars are going to speed up quicker than others. So these are all implemented at the class level. This is where the code gets done. The job of an interface is just to say what actions need to be present. What actions must I be able to do? I would say any car that doesn't allow you to turn is not drivable. And it wouldn't be street legal. We wouldn't be able to use it. Likewise, any car that doesn't allow you to slow down is not drivable. So let's use a different example and talk about this in a Java program. So instead of the drivable interface, let's think about a common interface in the Java language called comparable. Comparable. All right. So the comparable interface has one method and one method only listed, and that method is compare to. I'll say a type T, and we'll call it that'll be the name. So that T is kind of a placeholder for any object that you might want to compare things to. I can create a person object. All right. I can make a person object in Java. And if I implement the comparable interface, I must explain how to compare one person to another. Now, we might compare a person based on height, based on age, based on the alphabetic ordering of their first name or their last name. But if I implement this interface, I must write this method in this class. And by the way, this method returns an int, which is going to be 0 if we're the same, or it could be negative or positive to indicate order. Yeah, but why would we care? Why might this comparable interface be useful or worth implementing? Well, in part because there are other programs that are around that say, well, this is a really common interface. So if I can work with this, then any new class that's also comparable I can work with. For example, another very common class is the collections class. And one very common method in the collections class is the sort method. And sort can sort anything that is comparable. So if I have, I should have a list actually, any list of comparable objects. And we'll call it O here. Well, I'll give it a little L. So collection says, hey, if you give me a list of things that are comparable, I'll sort them for you. That's really useful. So now if I were to make a new program and say I'm going to have a list of people in a school, maybe I want to organize those people by alphabet, by their age, in which case my compare to is going to explain how to sort people by or compare to people based on age, or not by age, by name, sorry. Once I've done that, I can now use the collections class to organize them. Likewise, I might have another class called basketball player. Ball player. And perhaps here, I want to compare by height. I just want to know who's the tallest basketball player. All I need to do is write this method. So here I might say int compare to another basketball player, we'll call it B, would be return height minus B dot height. So give me the difference between their height. But now that I've written this really simple method in this class, which would also have to implement comparable at the top. So public class, I'm going to change this to b-ball player because that'll be a lot shorter for me to keep rewriting. B-ball player, b-ball player. All I need to do is say implements comparable. A ball. And then as soon as I say implements comparable, my IDE is going to expect me to write this method. And if I do that, I've done it. I've implemented the comparable interface. And now I've opened myself up to interacting with lots of other programs and files that are going to be really useful for me. So having a common interface for somewhat similar methods or classes that might be treated the same way is a really nice way to design big systems and networks of programs. Hope you found this helpful. Bye now.